2005 National Electrical Code, specifically Section 422.12, includes an exception that permits non-coincidental loads to share the same branch circuit. This exception extends beyond explicitly listed items like air conditioners and central heating systems, applying to other loads with non-overlapping usage patterns. For loads to be deemed non-coincidental, their operation must not occur simultaneously or exhibit minimal overlap. The underlying principle is that the maximum demand on the circuit remains below the sum of the individual loads. In situations where loads might potentially operate simultaneously, installing a switching device such as a control or timer is permissible to prevent concurrent operation, but with specific conditions. Firstly, the switching device must possess a rating equal to or exceeding the total load current. Secondly, the switching device must be implemented in a way it guarantees loads cannot be inadvertently operated at the same time. Thirdly, the cumulative circuit load, including all switched loads, must not surpass the circuit's designated rating. For example, imagine a branch circuit with a rating of 20 amps. On this circuit, it is possible to install an air conditioner drawing 15 amps and a space heater drawing 10 amps, given the implementation of a switching device. By using such a device, the air conditioner and space heater are prevented from operating concurrently, thus ensuring that the total load remains within the circuit's 20 amp limit. However, caution should always be exercised when making any electrical system changes. It is essential to consult a qualified electrician to ensure full compliance with all relevant codes, regulations, and safety standards. Before doing any electrical work, always verify that the power is switched off to the area that is being worked on. It is also imperative to have some basic electrical knowledge or receive assistance from a qualified professional. Never work alone, and always have a plan for how to deal with any unforeseen issues. In addition, the equipment and materials being used must be rated to the appropriate voltage and amperage. Use the right tools for the job and never take shortcuts. The NEC is a comprehensive set of standards and guidelines for electrical installations in the United States. It is updated every 3 years to reflect changes in technology and best practices. The NEC is not law, but it is widely adopted by state and local jurisdictions. Section 422 of the NEC covers appliances. It provides requirements for the installation, wiring, and protection of appliances. The new exception in 422.12 of the 2005 NEC allows non-coincidental loads that are not explicitly mentioned in the code to share the same branch circuit. This exception is based on the principle that the peak demand on the circuit will be lower than the sum of the individual loads. To be considered non-coincidental, the loads should not operate or be used simultaneously or have minimal overlap in usage patterns. For example, an air conditioner and a central heating system are typically considered non-coincidental loads because they are not likely to be used at the same time. However, it is important to note that the specific requirements for non-coincidental loads may vary depending on the local jurisdiction. Therefore, it is always best to consult with a qualified electrician before making any changes to electrical system. Installing a switching device, such as a control or timer, to prevent loads from operating simultaneously would be permitted under certain conditions. These include, firstly, the device must be rated for the total load current. Secondly, the device must be used in a manner that ensures loads cannot be accidentally operated simultaneously. Thirdly, the total circuit load, including the loads that are switched, must not exceed the circuit rating. Consider a circuit rated for 20 amps. You could install the following loads in the same circuit if a switching device is used. Firstly, an air conditioner that uses 15 amps and secondly, a space heater that uses 10 amps. By using a switching device, you are ensuring that the air conditioner and space heater will never operate simultaneously, preventing the total load from exceeding the circuit rating. There are a number of different types of switching devices that can be used to prevent loads from operating simultaneously. Some common types of switching devices include manual switches, timers, and automatic controls. Manual switches are the simplest type of switching device. They allow the user to manually turn loads on and off. Timers can be used to automatically turn loads on and off at specific times. This can be useful for loads that are only needed for a certain period of time, such as a space heater. Automatic controls can be used to automatically turn loads on and off based on certain conditions, such as temperature or occupancy. This can be useful for loads that are only needed when certain conditions are met, such as an air conditioner. When selecting a switching device, it is important to choose a device that is rated for the total load current. The switching device must also be used in a manner that ensures loads cannot be accidentally operated simultaneously. Finally, the total circuit load, including the loads that are switched, must not exceed the circuit rating. Here is more information on how to determine if loads are considered non-coincidental. Non-coincidental loads are loads that are not likely to be used at the same time. For example, an air conditioner and a central heating system are typically considered non-coincidental loads. However, it is important to note that the specific requirements for non-coincidental loads may vary depending on the local jurisdiction. Therefore, it is always best to consult with a qualified electrician before making any changes to electrical system. Factors to consider when determining non-coincidence include load types, usage patterns, and control mechanisms. Consider the types of loads being connected to the circuit. Air conditioners and heaters are classic examples of non-coincidental loads because they serve opposing functions and are typically not needed simultaneously. Analyze how the loads are typically used. If one load is primarily used during the day and the other at night, or if they are used in different seasons, they can be considered non-coincidental. Implementing controls like timers, occupancy sensors, or manual switches can ensure that loads do not operate at the same time, making them non-coincidental by design. To ensure electrical safety and compliance, it's important to follow these best practices. Firstly, perform a load calculation. Calculate the total load of each appliance or device that will be connected to the circuit. This involves summing the current in amps that each load draws. Secondly, consider the circuit capacity. Ensure that the total load does not exceed 80% of the circuit breaker's rating. For example, for a 20 amp circuit, the total load should not exceed 16 amps. Thirdly, consider using a switching mechanism like a DP/DT switch for manual control. In this setup, one load is active while the other is necessarily inactive, ensuring no overlap. Fourthly, when a timer or automated switch is used, program it to prevent simultaneous operation of the loads. Verify that the control mechanism is reliable and foolproof. Fifthly, always consult with a qualified electrician before making any modifications to electrical circuits. They can assess the specific situation and ensure that all work complies with local codes and regulations. To reiterate, firstly, the National Electrical Code (NEC) permits the sharing of a single branch circuit by multiple loads, especially when these loads are deemed non-coincidental. Secondly, for loads to be classified as non-coincidental, they should not operate simultaneously or have minimal overlap in their usage patterns. Examples of non-coincidental loads include air conditioners and heating systems, which generally operate at different times of the year. Thirdly, a switching device can be used to prevent simultaneous operation of loads that might otherwise be used at the same time. This is permissible provided the device is rated for the total load current and is designed to ensure that loads cannot be accidentally operated at the same time. Fourthly, the total circuit load, including the loads that are switched, must not exceed the rating of the branch circuit. For example, a 20 amp circuit could accommodate a 15 amp air conditioner and a 10 amp space heater if a switching device ensures they never operate simultaneously. Fifthly, any modifications to an electrical system should be performed in accordance with all applicable codes and regulations, and it is recommended to consult with a qualified electrician before making any changes. By adhering to these best practices, it is possible to safely and efficiently manage electrical loads, ensuring both convenience and safety. Additional examples of non-coincidental loads include lighting and ventilation, power tools and shop lighting, and kitchen appliances. Consider a scenario where a room's primary lighting is rarely used when the ventilation fan is running, or vice versa. Proper placement and control mechanisms can make these loads non-coincidental. In a workshop setting, heavy power tools that consume significant power might be used at different times than the general shop lighting. Dedicated circuits and thoughtful usage can prevent overload. Certain kitchen appliances like a microwave and a toaster oven are unlikely to be used simultaneously, particularly if kitchen layout and usage patterns separate their operation. Proper planning and switching mechanisms, when necessary, allow for the safe and efficient sharing of electrical circuits among non-coincidental loads. This approach optimizes electrical infrastructure while maintaining safety and compliance with the electrical codes. Again, always consult with a qualified electrician to ensure adherence to local codes and regulations, as well as to address any specific circumstances of your electrical system. Remember that electrical work can be dangerous and should only be performed by qualified individuals. It is always better to be safe than sorry when it comes to electricity. The NEC is a living document, and it is constantly being updated to reflect changes in technology and best practices. It is important to stay up to date on the latest changes to the NEC to ensure that all electrical work is performed safely and in compliance with the code. The NEC is a valuable resource for anyone who is involved in electrical work. It provides detailed information on how to install, wire, and protect electrical systems. The NEC is also a valuable resource for homeowners who want to learn more about their electrical systems. The NEC is available for purchase from the National Fire Protection Association (NFPA). The NFPA also offers a variety of training courses on the NEC. Taking a training course is a great way to learn more about the NEC and how to apply it to electrical work. This information is for educational purposes only and should not be considered a substitute for professional advice. If you have any questions about electrical work, please consult with a qualified electrician. Safe electrical practices must be followed at all times to prevent the risk of fire or injury. Always turn off the power at the breaker before working on any electrical circuits. Use caution when working with electricity. If you are not comfortable working with electricity, please consult with a qualified electrician. Electrical safety is a crucial aspect of any electrical installation, whether it is in a residential, commercial, or industrial setting. Understanding the potential hazards and implementing appropriate safety measures can significantly reduce the risk of electrical accidents, injuries, and property damage. Firstly, always de-energize circuits before working on them. The most fundamental safety practice is to always turn off the power supply to the circuit or equipment you are working on. This can be done by switching off the appropriate circuit breaker or removing the fuse that supplies power to the circuit. Verify that the circuit is de-energized by using a voltage tester before touching any wires or components. Secondly, use appropriate personal protective equipment. When working with electricity, it is essential to wear appropriate personal protective equipment (PPE) to protect yourself from potential hazards. This may include safety glasses, insulated gloves, and appropriate clothing. Insulated gloves are especially important when working with energized circuits or equipment, as they provide a barrier against electric shock. Thirdly, follow lockout/tagout procedures. Lockout/tagout procedures are designed to prevent accidental energization of equipment during maintenance or repair work. These procedures involve placing a lock and tag on the circuit breaker or disconnect switch to indicate that the equipment is being worked on and should not be energized. Fourthly, maintain a safe working distance. When working with energized circuits or equipment, maintain a safe working distance to avoid accidental contact with live parts. The safe working distance depends on the voltage level of the circuit or equipment. Fifthly, use insulated tools. Use only insulated tools when working with electricity. Insulated tools are designed to protect you from electric shock if you accidentally come into contact with a live wire or component. Sixthly, avoid wet conditions. Avoid working with electricity in wet conditions, as water can conduct electricity and increase the risk of electric shock. If you must work in wet conditions, use extra caution and wear appropriate PPE. Seventhly, inspect electrical equipment regularly. Regularly inspect electrical equipment for signs of damage or wear, such as frayed wires, cracked insulation, or loose connections. Repair or replace any damaged equipment immediately to prevent potential hazards. Eighthly, follow electrical codes and standards. Adhere to all applicable electrical codes and standards, such as the National Electrical Code (NEC), when installing, maintaining, or repairing electrical systems. These codes and standards provide guidelines for safe electrical practices and help to prevent electrical hazards. Ninthly, provide electrical safety training. Provide electrical safety training to all employees who work with or around electricity. Training should cover topics such as electrical hazards, safe work practices, and the use of PPE. Tenthly, use ground fault circuit interrupters. Ground fault circuit interrupters (GFCIs) are designed to protect against electric shock by detecting ground faults and interrupting the circuit. GFCIs should be used in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. By following these electrical safety practices, you can significantly reduce the risk of electrical accidents and injuries. Electrical safety is everyone's responsibility, and it is essential to take the necessary precautions to protect yourself and others from the hazards of electricity.